So in our last class, we were finding these trig values and angle values. And this is stuff that we just went over on the Kahoot. And as I said, this right here is just so important, knowing that first quadrant. Because if we know the first quadrant of the unit circle, then we can apply those to find all the values in the other quadrants. But today we're going to take it one step further and just do a little arithmetic and some equations with that stuff. So for example, in problem number 7, we want to find the exact value of the expression without the use of a calculator. So if we want to find the sine of pi over 4, so remember looking at your first quadrant of the unit circle, sine of pi over 4 is root 2 over 2. Plus 2 times the cosine of 5 pi over 4. Well, the cosine of 5 pi over 4, I know that 5 pi over 4 is in the third quadrant. The reference angle is pi over 4. The cosine is the x value, which is root 2 over 2, but it's going to be negative because it's in the third quadrant. So I have negative root 2 over 2. Okay, I have one more step left, but are there any questions on what we've done so far? Okay, so we're really just applying what we were doing the other day. It just, it's just a little bit more, right? So let's cancel the 2's here, and I've got root 2 over 2 plus, or I guess minus, right? Minus root 2, which if I want to combine them, I could make a common denominator. So I made the right side 2 root 2 over 2. So now I subtract 1 root 2 minus 2 root 2 is negative 1 root 2 over 2. We've just kind of upped things a little bit by adding a couple more steps and a little arithmetic in there. But most importantly, using those other values that we were talking about. All right, let's do part B. If you want to find the cotangent of 2 pi over 3, and then I'll do the sine of pi over 4 in just a minute, but I'm going to focus on this part. I know that 2 pi over 3 is in the second quadrant because 2/3 is less than 1, right? It's in the second quadrant. Our reference angle is pi over 3. And the cotangent is the cosine over the sine. Now in the second quadrant, the cosine would be negative 1/2. And the sine would be root 3 over 2. Okay, again, because my reference angle is pi over 3, so my cosine is negative 1/2. And my sine is still positive because it's in the second quadrant, root 3 over 2. So I'll clean that up in my next step. Yes?
How do you know that they're dividing?
How do I know that they're divided? Because it's a cotangent. And the cotangent is the cosine divided by the sine. Because, remember, tangent is sine over cosine, so I just flipped that over. So I just flipped over the tangent. Okay, let's keep rolling here. The sine of pi over 4 is the y value of pi over 4, which is root 2 over 2. So that's the first part, is getting the correct values. Are there any other questions on how I got those? All right, so now let's do a little arithmetic to clean this up. Remember, if I divide by 2, I can cancel those. I have negative 1 over root 3. I'm probably going to need to rationalize, and I will in just a moment. That's going to be times root 2 over 2. So if I multiply top and bottom by root 3, that's going to be negative root 3 over 3 times root 2 over 2. Giving me a final answer of negative root 6 over 6. Okay, any questions on 7 before I move on to 8? All right, 8 is a similar idea, but what we're going to do is we're going to find our answer for theta solving this equation. All right, when you guys walked in today, remember theta is a variable, okay? If I asked you guys to solve the equation, don't write this down because I'm going to erase it, but if I said, hey guys, solve 2x minus 1 equals 0, you would think that's an easy problem. You move the 1 over, divide by 2, and you're done. We're going to follow the same process. I'm going to move the 1 over, so I have 2, this you should write down, 2 sine theta is equal to 1. I just added 1 to both sides. And then I'm going to divide by 2. So we have the sine of theta is equal to 1/2. But we're trying to solve for theta, not the sine. Now I need to figure out, well, what angles is the sine equal to 1/2? Remember, the sine is the y value. So I know in the first quadrant, the y value is 1/2 at pi over 6. That's one of my answers. So theta equals pi over 6. And it will also, sine would be positive, because sine is a y value. It would also be positive in the second quadrant at 5 pi over 6. Those are my two values for theta. Now notice the direction said, over the interval from 0 to 2 pi. So that means just one loop around the unit circle. And because we could keep going around and do like 2 pi plus pi over 6, like 13 pi over 6 would be another answer, but that would be more than one loop around the unit circle. So we're just adding in some algebra now and then applying some of these trig functions. All right, let's do part B. So again, think of this as 4x minus root 3 is equal to 2x. Well, you would get your x's on one side and your numbers on the other side. So that's what I'm going to do here. I'm going to move that guy over. So 4 sine theta minus 2 sine theta would be 2 sine theta. And I'm moving the negative root 3 over, and that's going to be positive root 3. So my first step, I get 2 sine theta equals root 3. So now the sine of theta is equal to root 3 over 2. So where sine is the y value, where is the y value? Positive root 3 over 2. Well, at pi over 3, that's one of my answers in the first quadrant. That's my reference angle. So theta would be pi over 3. And then remember, sine being a y value is also positive in the second quadrant at 2 pi over 3. All right, part C. This doesn't look like it, but, or maybe it does. It's a zero product property question. Meaning, I set this equal to 0, and I set this equal to 0, and I solve both of those. Okay, just like if you had a, something like, I don't know, x minus 3 times x plus 1 equals 0, you would use the zero product property in that case also. So we're using that same concept here. I have two equations, the cosine of theta plus 1 equals 0, and the tangent of theta equals 0, and I have to solve both of those. So on the left side, I move the 1 over, I have the cosine is equal to -1. The right side, I don't have to do any algebra manipulation with, but I do need to write my answer. My answer can satisfy either one of those. So where is the cosine equal to -1? Cosine is the x value. X value is -1 at pi. So pi is one of our answers for theta. Okay, because that satisfies the first part. Second part, where is the tangent equal to 0? Well, remember, tangent is sine over cosine. And so whenever the sine is 0, because 0 divided by anything will be 0. So where is the sine equal to 0? Well, that is straight to the right at 0 and at 2 pi. So pi and 0 and 2 pi are my answers. Yes, Libby.
Oh, wait, now I answered that question.
Okay. Are there any other questions before I go on to another one here? All right, well, let's skip D here. I think you guys are getting that, but E has a different element to it. It looks the same, and it is very much the same. But there's one thing that we can't forget. I have sine squared theta. Oh, by the way, I should have mentioned this. I'm going to erase this in a second, guys, but this notation is a little different than what we're used to. Sine squared theta, that means if you take the sine of theta and then square the whole thing, like you're not squaring the angle, you're taking the side of the angle and then squaring it. Okay, it's just written in a different spot. It's not really what we're used to, but I just don't want you to be too confused about that. I'm going to solve it algebraically. I'm going to move the 1 over, and this you probably should write down. So I have sine squared theta is equal to 1. And now I have to take the square root of both sides. So I get sine of theta is equal to the square root of 1, which is, do not forget, plus or minus 1. Don't forget the plus or minus, because it's going to give us more answers, of course. So sine is the y value. Where is the y value equal to positive or -1? Well, it's positive 1 at pi over 2. And it's -1 at 3 pi over 2. So those are my two solutions. That theta equals pi over 2 and 3 pi over 2. If I forgot the plus or minus, I would only then have the pi over 2, right? I wouldn't have the 3 pi over 2. All right, and F, similar problem. I think I can factor a cosine, a GCF, factor a cosine out of the left-hand side. So I get cosine theta times cosine theta minus 3 is equal to 0. Because I'm just factoring it. And it might be helpful for some of you to, write it down even if you want to, but think of that as, if you had x squared minus 3x equals 0, you would factor in x out of there. I did the same thing. I just factored a cosine theta out of that part. All right, now I'm going to use the zero product property. I'm going to set this equal to 0 and set this equal to 0. So I have cosine theta equals 0. I'll solve that in just a second. And cosine of theta minus 3 equals 0. Which I got to move the 3 over, so I get cosine of theta equals 3. So cosine is the x value. So this is saying, where is the x value equal to 0? Well, let's take a look. The x value is equal to 0 at pi over 2 straight up and at 3 pi over 2. So the left side, our answers are pi over 2 and 3 pi over 2. Now this is saying, where is the cosine of the x value equal to 3? It never is. Right? It's never equal to 3. It's really nice when that happens. We don't even have to worry about it. Because cosine never does equal 3. So we only have those two answers at pi over 2 and 3 pi over 2. All right, I'm going to up the ante one more time, but before I do so, are there any questions on these where we're solving the equations and then writing our solutions? Any questions on those from problem 8? All right. I'm going to write a problem down. Don't write it down because I'm going to change it in just a minute. If we did this problem, I think you guys would be perfectly fine with this. If I said, all right, can you solve the cosine of theta is equal to, let's say, -1/2. Okay, that question is asking, where is the x value? -1/2. Well, I know it's +1/2 at pi over 3. So the cosine of the x is negative in the second and third quadrants. So my answers there are that theta would be in the second quadrant 2 pi over 3 and in the third quadrant 4 pi over 3. Okay, just kind of what we were doing before. But now I'm going to change that problem. So this I do think you should write down. What if it wasn't cosine theta, but I said the cosine of, let's say, 2/3 theta is equal to -1/2. All right, well, here's how you want to approach this. You want to train yourself to just kind of think of that as theta, or maybe a different variable. Think of it as x. Okay, so in the last problem, I knew that my x was equal to 2 pi over 3 and 4 pi over 3. I'm going to use that same logic, but now I have 2/3 theta equals 2 pi over 3, and 2/3 theta equals 4 pi over 3. Now, I'm not done yet. I still have another step to do. But the problem on the left in blue is closely related to the problem on the right in green. Okay, I just am kind of setting that whole stuff in parentheses, the 2/3 theta equal to 2 pi over 3 and 4 pi over 3. Because now I then can, to solve for theta, well, let's see, I can multiply by the reciprocal, right? Multiply both sides by 3/2. And I'll do that same on both of them. And so my answers, let's see, my 3's cancel, 2's cancel, I get theta equals pi on the left. And on the right, theta equals 2 pi. All right, maybe we do one more like that. So those are a little tricky. All right, so let's try one more example. I'm sorry if you were still right there. All right, this will be the last example. Let's say the sine of 4/5 theta is equal to √3 over 2. So think of this as kind of one part. So where is the sine equal to √3 over 2? Well, the sine, meaning the y value, is equal to √3 over 2 in the first quadrant at pi over 3, and since it's a y value in the second quadrant at 2 pi over 3. So we set this equal to pi over 3 and equal to 2 pi over 3. So I do 4/5 theta equals pi over 3. And 4/5 theta equals 2 pi over 3. And now I got to solve this for theta. So multiply both sides by 5/4 all around. And let's see, when we do that, we get theta equals 5 pi over 12 on the left part. And I still have to do the right side. So on the right side, I get theta equals 5 pi over 6. 10 pi over 12, right, which is 5 pi over 6. All right, I know those last couple are kind of tricky. Are there any questions on those?